Thank you very much. Thank you. So I have chosen the article of Alexander Fleming on the discovery of penicillin following a lab accident that fascinated me, in a way led me to the field of infectious diseases, as I will explain. That's why the title is Captured by the Discovery of Penicillin. I have no conflict of interest to declare, neither I guess has Alexander Fleming. So, in the year 1972, not 25, in 72, I was a 21-year-old, third-year medical student, young, curious, and enthusiastic. I'm still curious and enthusiastic. And Theo Sachs was a great teacher, a role model, and he began the course of antibiotics by bringing physically in his hands the article of Alexander Fleming. As you know, at that time, no PubMed, no internet, no PC. And he described the discovery of penicillin and new classes and their great impact. At the end of the lecture, I asked for the article, read it, and indeed was fascinated. This opened the antibiotic era that has changed the whole practice of medicine. This was the golden age of antibiotics, the 70s, with nearly every year or two, new classes of antibiotics were discovered and introduced into the clinical arena. This is a PDF version of the article from Google Scholar, and it is indeed very impressive. A single author from the inoculation department, and this is the original picture of the contaminated plate that I would have probably thrown away, but he paid attention to the lysis of the staphylococci on this plate. And this is 11 pages, very busy pages, that describes several years of study, which describe the isolation of the antimicrobial substance, the properties, the effects of various bacteria, concentration, and also toxicity. Just for example, this is morphologically the effect of different bacteria. This is quantitatively the dilutions, different species, different strains, and also the effect of timing outside the refrigerator with concentrations and so on. Interestingly, only 4 references. So over the years, we have done several studies, clinical studies on antibiotics, I guess as many of the audience here. But in addition, we have explored very interesting non-antimicrobial effects of antibiotics in our basic research lab. For instance, on the inflammatory mediators, such as gamma interferon, IL-1 and IL-8, the mechanisms involved, the role of NF-kappa B and other pathways, nitric oxide production, its effect on microRNA, and so on. Dear colleagues, after 83 years, we have no acronyms, MRSA and MRSE, VRE, VISA, VRSA, and for gram-negatives, ESBL, CRE, KPC, multi-drug resistant bacteria, for instance, pan-resistant Acinetobacter baumannii. And the WHO has declared that antibiotic resistance is one of the top 10 global public health threats facing humanity. Indeed, a very comprehensive systematic analysis of 204 countries concluded that each year their estimate of about 5 million deaths associated with bacterial resistance, of which 1.27 million are attributable to mortality to these resistant bacteria. And this is in developed countries as well, as you see in Europe and other North America. With the important concept of One Health it has been shown that the major rivers of our planet are contaminated with resistant bacteria. This has led to the question, are we reaching the end of the antibiotic era? Is it possible? Well, since 1941, there are only 2.7 human generations, but about 54,000 bacterial generation, which is significant in terms of evolution. Worldwide, there are 8.1 million humans, but about 10 to the 34 human bacteria. And in our body, as we have heard yesterday, we have about 10 to the 14 bacteria, 19% of our cells. And dear colleagues, what do we do in this ecosystem? It has been estimated that each year we use 200,000 tons of antibiotics every year. Interesting, about 50% are non-human use in veterinary medicine, fish ponds, agriculture as growth promoters, coating ships, etc. So, a selective pressure is caused with multiple advanced resistant mechanisms, and experts say that the increasing antibiotic resistance nowadays outpaces the development of novel antibiotics. I think one of the take-home messages, dear colleagues, is that we should think also outside the box, trying to explore non-antibiotic antimicrobial therapy, such as novel immunotherapies and inhibition of worm sensing, inhibit toxin production, bacterial adherence, bacteriophages, and so on. Obviously, I don't have time to go into detail. But just let me emphasize that some of these methods do not kill the bacteria, thus causing less selective pressure and reduction of resistance. We should try to be the parents of our future, not only the offsprings of our past. In fact, proofs of concept of these novel approaches have been documented, and again, I will not go into detail, including by our group, and I do hope that these innovative approaches will make the transition from the research lab to the clinical arena. Thank you.